Welcome to today's lesson. Today we are going to be looking at early astronomers and discoveries. So far we have been studying space, right? We have been exploring space, how we have day and night, different seasons, and then we look at the solar system. Today we want to look at how this knowledge that we have been learning, this understanding that we now have about space, came into existence and how the processes pass through. All right, in those days or during the Stone Age or early age, there were no sophisticated instruments. All right, so knowledge were built as a result of mathematical calculations and then theoretical beliefs, okay, concerning the solar system. This knowledge, as they were building them from generation to generation, from century to century, it now formed a branch of science which we call astronomy. Okay, it is this branch of science that we now call astronomy. But astronomy started as a result of theoretical and mathematical calculations. This did not have proof as at then. All right, we look at astronomy now, which is now a branch of science. It is that branch of science that studies celestial objects and then phenomenon. By celestial or by phenomenon, we mean the happenings, the things that has happened before, the things that are happening now, and the things that are likely to happen, all right, in certain future years. Then by celestial objects, we mean the planet, the moon, the stars, which the sun is one of, and then you have nebula, which are a mixture of gases and dust, okay, which are visible at dark hours. Then you have galaxy, in which the Milky Way is one of, and then you have comets, which are icy-like materials, also orbiting or revolving the sun, but at a very far distance, producing what? Icy, gaseous materials. But an astronomer is a scientist in the field of astronomy. That is, somebody that studied astronomy should be astronomer, right? Yes. Just like somebody that studied engineering is an engineer. So also an astronomer is somebody that studied astronomy. He focuses his attention on things that are beyond Earth, okay, that are beyond the scope of Earth. If it is within the Earth, it is not astronomy. But so long as it has to leave the Earth to space, you are dealing with what? Astronomy. And such person is an astronomer. So we want to look at early history about some of these astronomers. Okay, it begins from 150 AD. 150 AD we mean 150 Anno Domini. Now Anno Domini is the date we use to count, or is the counting date after Jesus Christ's death. Okay, some people call it after death. The real name is Anno Domini. So astronomy began, and the theory was put forward by Claudius Ptolemy. All right, he believed that the sun moved around the Earth. That was his own belief, and that was what he calculated from his own mathematics. I told you before that there were theories. A theory is something you just calculate. You have not proved it experimentally. Okay, is what we call a theory. If you now prove it experimentally and then it is correct, that is, you carry out a practical and it is correct, you will not call it a law. Do you understand? Yes, I know you understand. So Ptolemy, or Claudius Ptolemy, his own belief from his own calculation was that the sun was the one moving around the Earth. That is, the Earth was the center. And then by 500 AD, another Indian astronomer, Aryabhata, had discovered that the Earth spun on its axis, or on its own axis. But even though he discovered that, because he didn't discover that the Earth was actually spinning and orbiting, he only discovered that the Earth was actually what? Spinning on its own axis. He now also believed that the Earth was the center of the universe. Are you getting it now? So Ptolemy and Aryabhata have the theory that the Earth is at the center, while Ptolemy holds to the fact that the sun is revolving or orbiting the Earth. And you know why? Because we've discussed it earlier that it appears as if the sun is rising from where? The east, is it not? And setting in where? In the west. So it will look as if it was actually moving around the Earth. We can't blame him for that, right? Yes. But in the early 11th century, the Arab scientist IBM Al-Hattan now made observation, and then from his own calculation, he is now discovered that this thing that they are saying that the Earth is at the center of the universe is not really true. It's not true, because my calculation is not giving me this correct answer people are saying. From my calculation, the Earth cannot be the center of the universe. Then by the 15th century, you know century is 100 years, right? So you can calculate it. By the 15th century, so 11th to 15th century, that will give you 400 years, is it not? Scholars like Akushi had found more evidence that the Earth moved around the sun. Okay, so Akushi, when he now studied all this theory that was put forward by Plotiny and the rest, which include the Earth being the center, and then the one put forward by this Al-Hattan, which is questioning that it is not so, that the Earth can be the center. So Akushi now found out that the Earth moved around the sun and not the other way around, which was given by Ptolemy and believed by Aryabhata. Alright? Yes, Aryabhata. So him himself, now I'm talking about Akushi, he now discovered that it is not so. It is actually the Earth that is what? Orbiting the sun. And then by 1514, a Polish astronomer known as Nicholas Copernicus also put forward this same theory, but many people did not want to believe him. You know, change is not something that is easy. People are already used to the sun moving around the Earth. So these calculations that were brought forward were accepted, but people did not really believe it, because I told you before that they are all theories, you know, no practical then. So you can say whatever you want to say, they will put it down, but they know what they believe as and then. But if you have a proof, they will now accept it, as we will now see. So let's take a look at Nicholas Copernicus. He was a mathematician and also astronomer. He formulated a model of the universe that placed the sun rather than the Earth at the center. So it was one that brought the real change, or the real correct foundation of the solar system. Okay, at the center of the universe. In all likelihood, there is one scientist who called Aristarchus of Samos, who had also formulated such models some 18 centuries earlier, but it was him that actually brought this theory into existence. So the credit was given to him. I'm talking about Nicholas Copernicus. All right. A few years later, an Italian scientist known as Galileo Galilei now built a more advanced telescope. You know what the telescope is, right? His own telescope has a powerful lens that was able to see space. So based on an earlier one he had seen before, he now used this telescope to look beyond, Earth, and then he saw Jupiter. He was one that now discovered Jupiter's 4 largest moons. He now saw these 4 moons revolving or orbiting Jupiter. He observed the moons moving around Jupiter. This is discovery now also supported the evidence that was put forward earlier by Akushi and Copernicus. Alright? So look, Galileo di Vincenzo Bonatti or Benotti di Galilei, that is his full name. He's a very, very great scientist, or was a great scientist. He discovered a lot of things in science, alright? Among some theories you will study as you go on in your educational pursuit, alright? But he is known as an Italian astronomer, a physicist, and an engineer. right? But his discovery cut across a lot of fields, both science, engineering. Finally, in the 17th century, the mathematician Johannes Kepler confirmed the motion of the planet around the sun. Okay, it was Johannes Kepler that now confirmed that it is the planet that are actually orbiting around the sun, in which we now have the solar system. All right, and then Isaac Newton's law of motion and the discovery of gravity now provided a scientific explanation for the work done by Arcouget and Copernicus. So these people now prove that Arcouget and Copernicus were right and not Ptolemy. Okay, they are discoveries. Isaac Newton, you will learn as you go on. Those of you that go to science now discover motion and gravity. Let's take a recap of this brief history we've talked about today. It all started from Ptolemy and Aibata. Ptolemy was the one that placed the Earth as the center. Aibata was the one that discovered that the Earth was actually spinning, but he also believed that the Earth was the center. Okay? While Hatan made observation and calculation and questioned the idea of the Earth being at the center. It was then that Arcouget and Nicholas Copernicus now carried out more research and discovered that the sun is at the center and not the earth. But many people did not want to believe this idea, okay? But Galileo now built a more advanced telescope, which of course now created the proof that actually the earth is not at the center, okay? And then finally, in the 17th century, the mathematician Johannes Kepler now confirmed the motion of the planet around the sun, and the Isaac Newton law of motion or laws of motion and discovery of gravity now provided the scientific explanation for the work done by Arcouget and Copernicus. And that now brought us to the knowledge of the solar system with sophisticated instruments available like the NASA robots that is sent by the Arizona University now made us to understand properly that these theories were actually correct. I want you to pay attention to this brief history on discovery of the solar system. All right?
Astronomy is the study of the planets, stars and everything else in space, and is one of the oldest natural sciences in existence. From ancient civilizations simply looking up at the night sky, to modern astronomers using a telescope capable of seeing 15 billion light years away, astronomy has always been an important and fascinating part of human history. In its earliest form, astronomy was closely tied to mythology. Most of the work done in ancient times has now been lost, but much of it is known to us because of a man called Claudius Ptolemy. Sometime around AD 150, he completed the Almagest. This was an extended documentation of the collective astronomical knowledge from the prior few centuries. It was considered one of the most important scientific works of all time. Despite how influential it was, unfortunately it did firmly cement the geocentric model of the universe among the scientific community. This model puts the Earth as a stationary object in the centre, with the Earth and other planets revolving around it. He even came up with his own model, which involved epicycles. This helped explain some anomalies in the planet's movement that weren't consistent with the current model. Skipping forward a little to the Middle Ages, which was a comparatively quiet time for European astronomy. Too busy killing each other probably. Conversely though, this was considered a golden age for Indian astronomy. One of the most important figures was Aryabhata, circa 500, who was way ahead of his time. He suggested that the Earth rotates around its axis every day, asserting that it was the Earth that was moving, not the stars. But this idea didn't catch on at this time. He also managed to determine the length of a sidereal year, accurate to 3 minutes from modern calculations. Another Indian was Bhaskara II from the 12th century. His extensive work in both mathematics and astronomy was divided into 4 parts, with several chapters outlining a multitude of data on the sun, moon, planets and stars. Indian astronomy was a big influence to the Islamic world, who experienced a golden age around this time. Muslim scholars were possibly the first to really question the Ptolemaic model and even geocentrism in general. One of the most important suggestions by a Persian astronomer was that the planets and stars are subject to the same laws of physics that we are here on Earth. This may not sound like a big deal, but at the time, thinking that things in the sky could follow the same rules as things on Earth was a very different approach, especially when there were centuries of religious ideas caught up in the way people understood the so-called heavenly bodies, as they were still called in academic circles. After the Middle Ages, massive strides of progress were made in what became known as the Copernican Revolution, started by the works of Polish astronomer Nicholas Copernicus. This began with the assertion that, contrary to popular belief, the Earth was not the centre of the universe. Copernicus was by no means the first to suggest that it wasn't. In fact, it was suggested way back in 280 BC by Greek astronomer Aristarchus of Samos. However, he was the driving force that eventually led to the incredibly important paradigm shift in the scientific community, from a geocentric model to a heliocentric model, that is, with the Sun in the middle. Shortly after Copernicus came a huge turning point in astronomy, the invention of the telescope. Up until this point, all observations were limited to what could be seen with the naked eye. Liking what he saw, Italian astronomer Galileo wanted to get in on the action and made his own in the following year. In 1610, he discovered 4 moons of Jupiter, which today are known as the Galilean moons, Io, Europa, Ganymede and Callisto. He originally described them as stars wandering about Jupiter. This was the first time that objects were discovered that could definitively be shown to not revolve around the Earth, giving further credibility to the heliocentric model. One of Galileo's lesser known contributions to astronomy was observing the phases of Venus. The planet has phases similar to that of the Moon, based on the relative positions of the Sun, Earth and Venus. When the Sun is directly between the two planets, Venus is fully illuminated from Earth's perspective. Under the geocentric model, there is no scenario in which the Sun could possibly be between the Earth and Venus. In the age of the telescope, the geocentric model quickly began to fall apart. Unfortunately for Galileo, there were some who clutched onto the geocentric model despite the mounting evidence against it, the Catholic Church. Galileo's claims were said to contradict the Bible, and he was tried for heresy. He was forced to recant his statements under threat of torture and was placed under house arrest until his death in 1642. Another influential astronomer of this time was Johannes Kepler. He greatly improved our understanding of the solar system with his 3 laws of planetary motion. The first law basically states that planets don't revolve in perfect circles, but rather ellipses, and the Sun is not directly in the middle but at one of 2 focal points. The second law states that sections of this ellipse with equal areas take equal time for the planet to move across, so a planet does not always orbit with a constant velocity. The third law shows that a planet's distance from the Sun is proportional to its orbital period, with a simple formula of p squared equals a cubed. The scientific revolution is often said to have come to an end with none other than Sir Isaac Newton and his law of universal gravitation. This showed that the reason planets orbit the Sun is the same reason why an apple falls from a tree: gravity. It's the same force of nature, both here on Earth and out in space. Even after the invention of the telescope, it would still be more than 170 years for the first ever new planet to be found. The discovery came from British astronomer William Herschel, who actually thought he had discovered a comet. He originally wanted to name it Georgium Sidus after King George III, but this wasn't too popular outside of Great Britain. Some external name suggestions were Herschel, Neptune, and the name we know as today, Uranus, the Latinized version of the Greek deity Uranus. The man who suggested this was a German astronomer called Johann Elert Bode. He was best known for the Titus-Bode law, a now disproven hypothesis which predicted planetary distances. With the exception of the large gap between Mars and Jupiter, the law's predicted distances lined up pretty much with all the planets, including the newly discovered one. So this led to a thorough search between Mars and Jupiter as several astronomers attempted to find the supposedly missing planet. In 1801, it was thought that this task had been achieved. at the exact distance that Bode's law suggested, the missing planet was found, Ceres. The following year, yet another new planet was found in the same vicinity, Pallas. Shortly after, a third, Juno, and shortly after that, a fourth, Vesta. Astronomers became uneasy about just naming more and more new planets. However, for several decades there were no new discoveries made, and for nearly half a century, astronomy textbooks listed the 11 planets. A new celestial classification had been suggested by William Herschel in 1802, asteroid, Greek for star-like. This suggestion was almost universally adopted in 1845 when a fifth object was found, and all discovered objects between Mars and Jupiter were reclassified. These 5 would be the first asteroids in what would shortly thereafter be called the asteroid belt, which today is known to have possibly millions of asteroids. Just 1 year later, and an actual new planet was discovered, Neptune. It was discovered by German astronomer Johann Gottfried Galle, but its position had been hypothesized in the years previously by 2 other astronomers due to irregularities in the orbit of Uranus. It was this discovery that was the nail in the coffin for the Titus-Bode law, as Neptune was nowhere near where it should have been. The discovery of Pluto 84 years later would further confirm this, and ironically led to a similar dispute within the scientific community, but more on that later. The 20th century was an exciting time for astronomy due to the rapid technological advancements that were made. In the aftermath of World War II, the United States and Soviet Union got a hold of German V-2 rocket technology, which the US used to take the first ever photograph of Earth from space in 1946. As the Cold War tensions between the two superpowers grew, an intense cosmic rivalry emerged, known as the space race. This competition for space dominance began in 1957 when the Soviets launched Sputnik 1 into orbit, becoming the first man-made satellite in space. The USSR had several more iconic firsts in the 50s and 60s, the first animal in space, the first man in space, the first woman in space. Despite all the firsts that were achieved by the Soviets, the US ultimately managed one of the most iconic moments in not only astronomy but in human history.
It's one small step for man, one giant leap for mankind.
Neil Armstrong became the first human to set foot on the moon. This moment in 1969 was the de facto end of the space race. Not because this was an achievement that was insurmountable, it's just that the Soviet economy began to decline in the 1970s, leaving them unable to compete. Despite a slower start, it was clear that the US had now taken over technologically. From 1972 onwards, the superpowers shifted from competition to cooperation, beginning with the Apollo-Soyuz test project. Since the space race, technology has continued to improve, allowing us to see into the furthest depths of the solar system and far beyond. There have been several major milestones in the last few decades, such as the Hubble telescope, the International Space Station, and the Mars rovers, just to name a few. In 2006, for the first time, the word planet was given an official definition, with 3 criteria from the IAU. The new definition excluded Pluto, which has since been referred to as a dwarf planet. This was done because astronomers had been finding lots of trans-Neptunian objects similar to Pluto, creating the same kind of difficulties that scientists faced over 100 years before. These objects, along with Pluto and several thousand more discovered since, are collectively referred to as the Kuiper Belt. Of course, the solar system doesn't end here. In fact, anything that orbits the Sun can be said to be part of the solar system, and its gravitational field could potentially reach 2 light years away. The theorised Oort cloud is a spherical cloud made up of billions or even trillions of icy objects and is believed to be the limit of the solar system. Estimates put its expanse at 100,000 astronomical units. This is nearly halfway to the nearest star, Proxima Centauri. There is so much of the solar system that we have still yet to explore. Even returning closer to Earth, we still don't know everything. Today we know of the 8 planets, but many of us grew up learning about 9. In recent years there have been several astronomers searching for another 9th planet, which may very well be discovered someday. Or perhaps something much bigger, such as finding signs of extraterrestrial life. With recent discoveries of water on other planets, it might not be all that far-fetched. As we continue to explore outwards, our knowledge of the solar system will continue to improve and evolve, hopefully breaking new boundaries and hitting new milestones. As time goes on, our understanding of the solar system will be shaped by discoveries and innovations of the future for many years to come. Space exploration has impacted our lives here on Earth in ways you might not be aware of. Many technologies we take for granted these days, like the GPS in our phones, was originally a NASA technology. Looking at just how important NASA has been in shaping the world we live in is a great documentary I watched called A World Without NASA, which is available on CuriosityStream.
Welcome back. I believe you now have a basic understanding of astronomy and then some of the scientists that contributed to the field of astronomy. And in this class, you've learned that astronomers are scientists who study the universe and all of the objects within it. And you also learned that scientists have proved that the Earth moves around the Sun. That now brings us to the end of the class. I want you to do your assignment and stay safe. I'll see you soon.